In example 1, each of those parts, the greatest common factor that we pulled out was either an integer or a variable, x or x raised to some power. We can also have more complicated expressions as the greatest common factor, like we'll see in example 2. So when we look at these problems, even though they're starting to get more complicated, we want to recognize that what we have are still two terms. In part A, the first term is 7x times the quantity x minus 5, and being subtracted from that is the term 3 times the quantity x minus 5. So we sort of have to focus our eyes to see that difference, that what we have is just the difference of those two terms, and then we can start looking at what's common between each of those terms. There's nothing common between the 7x and the 3, but the x minus 5 in this case is common between both terms. So if we divide out or factor out that x minus 5, then what we'd be left with is the 7x minus 3. And we'll see that pattern repeated in the remaining examples. In part B, we have negative 3x times x plus 6. That's our first term. And the second term is 5 times x plus 6. So x plus 6 is the factor that's common between these two terms. So we can factor out x plus 6 and then just look at what's left over. In the first term, we just have negative 3x left over. And in the second term, 5 is the only thing left over. In part C, we have x minus 8 that's common between each of these terms. And what would be helpful is to recognize that we can always think of there being a 1 multiplied by anything that we want. So the second term is really 1 times x minus 8. So after we factor out that x minus 8 that's common between these two terms, what we're left with is 9x minus 1. In part D, again a similar pattern. We have x plus 1 that's common between both of these terms. So we can factor that out and look at what's left over. That will leave us with negative 3x minus 8. But in this case, we have one additional step we can take. If we look at this leftover piece, the negative 3x minus 8, we have something that's common between those two, or something that would divide into both of those. And in this case, that's negative 1. So we can factor out a negative 1, which will still be multiplied by x plus 1, that factor we already pulled out. And then what's left will be positive 3x plus 8. And then we could go ahead and write that more simply as just a negative sign times x plus 1 times 3x plus 8. Where that negative sign out in front reflects that we have a negative 1 being multiplied by this entire expression.